I'd like to tell you, just before we go, something about different virtual machines that are running today on a Cherry system near you. This is shall I say, an output of the Cherry Alliance Virtual Machines Working Group. Sadly, I think I'm the only person in the Virtual Machines Working Group who's working at the moment, but please come and join me. This is a call to arms. Come and join me in the Virtual Machines Working Group. I'll tell you more about that in a minute. Oh, just an aside, right? You might be thinking, well, I'm interested in platform virtual machines, kind of operating systems running in boxes. This isn't what I'm talking about here. If you're interested in that, talk to Hesham, who might be here somewhere. Hello, yes, good. There's your man there. But if you're interested in language level virtual machines, this is what you're interested in here. So, what is a virtual machine? So, I'm going to give you 3 ridiculous analogies, and I'd like you to choose which one you think is the most appropriate for a language level virtual machine. I've tried these on my undergraduate students, so see whether you think they're any good or not. A virtual machine is like a surfboard. So there are the wild, raging waves, and all that's between you, the application, and the deep blue sea is a very thin layer. But you can drive it and use it to go places. Analogy number 1. Virtual machine as surfboard. Number 2, virtual machine as life support. All that's keeping your application alive is these kind of wires that are pumping in things into you that are kind of needed to get you going. All the kind of important life juices are coming into you from the life support machine. Analogy number 2, virtual machine as life support system. Analogy number 3, I got this one from ChatGPT. Virtual machine as greenhouse. Imagine your application is an exotic plant and it can't cope with harsh Mancunian weather, so you put it in your greenhouse and have a nice warm environment, humid and lively and suitable for cultivating your exotic plants. So virtual machine is greenhouse. Who likes surfboard? Okay. Who likes life support machine? Who likes greenhouse? And who thinks analogies are ridiculous and shouldn't be used at all? Okay, there we go. Right, listen, managed language runtimes are really important because almost every language people are writing these days is going to run on one of these surfboard-like, greenhouse-like virtual machines, perhaps. Everyone's writing in Python, especially for AI. Well, some people are writing in C and C++, but even they have language runtimes, and they're very small and very thin. Yes, lots of JavaScript hackers and C# and Java and so on, so there's lots of managed languages out there. And to quote Robert Watson from not too long ago, is there... Yes, it's pointing roughly the right place. Good. Language runtimes are super interesting, certainly from a Cherry perspective. So, I'm going to give you, in the next few minutes, a little tour of virtual machines. These are all open source virtual machines, all freely available and can all be built on or cross-compiled for Morello CheriBSD. And some of them run on other Cherry systems like Sonata as well. And hopefully, when I can stump up enough cash, or Glasgow University can stump up enough cash, we'll get a CODASIP system to work on as well. So, number 1 is Ruby. Now, I wonder if I just put that down there. Yes, good. Okay, so the C Ruby interpreter was developed at the University of Tokyo in Japan, and it's available on GitHub, and this runs nicely on Cherry RISC-V in emulation and on Morello in real metal. There's a technical report available, which has been submitted to a conference and hopefully should be appearing somewhere soon. Good. So if I say CD Ruby... Good. So in here is a mini Ruby executable, which is a C64 executable, and I can say things like this: mini Ruby -e. Now let me get this right. I'm not very good at Ruby. 10 dot times put s hello world, and hopefully, if I've got my syntax right. Oh no! Well, // okay, thank you. Yes, good, let's try that. Come on. Oh, what's going on here? I should have changed my path, shouldn't I? Ha! Good. Okay, so this is working very nicely. And indeed, we can run a Ruby file. So here's a nice Ruby file here called gc.rb, which prints out the GC housekeeping information, runs a garbage collection, and then prints the housekeeping information again. Mini Ruby GC, this is just a simple mark sweep garbage collector, and we see that the garbage collector hasn't run. Oh, look, now the garbage collector has run. And just like David said before, here is very verbose JSON-like information, which may or may not be digestible. But it's certainly run a garbage collection for us. Good. And now, this is the nice one here. This came partly from a student and partly from a large language model, but here is a program which allocates a large array and then tries to loop over the array doing some sorting. But while it's doing the sorting, it's popping elements from the array and randomly sticking new elements into the array. And this program doesn't work nicely because look what happens when I run it on my mini Ruby crash.rb. Aha! Good. And that's what's supposed to happen because it's accessing memory that it's done a compacting garbage collection. It has no longer got access to and therefore shouldn't be able to access. And so we get the in-space security exception. But look at this. Now, this is interesting. Here is the hybrid interpreter for Ruby, which is not kind of pure capability. And if I run that on my crash.rb, it runs for a very long time and doesn't crash at all and is accessing memory it shouldn't be accessing. Haha. So that's good. WebAssembly. So if you're not using WebAssembly now, you will be very soon. WebAssembly is the portable intermediate representation that everybody cares about, or at least everybody who's anybody. And here is a lean WebAssembly interpreter developed in Belgium that we ported to Morello, and it's available on GitHub and it runs on CheriBSD. We're also trying to port it to Sonata, CHERIT, but we haven't got there just yet. It's very slow, but I shall demonstrate it to you here. So build pure cap. The nice thing about WebAssembly is it has this kind of compartmentalization built into it because memory is automatically bounded, and if you access outside of memory, then there are software bounds checks that crash your program, but of course we can do all that in hardware on CHERI. So let me see if I run WDC, I'm going to cheat here, WDCLI. Good, so I'm going to calculate the digits of pi. And very, very slowly, the bytecode is interpreted and the digits of pi appear on the screen. And this really is WebAssembly bytecode being executed on CHERI. And I shall disassemble the WebAssembly bytecode for you in a minute. It's going to stop. It is. I think it stops when it gets to the next digit, maybe. Or maybe not. Okay, never mind. But here we go. So here's the actual WebAssembly code that's being executed here to calculate the digits of pi. So we can run WebAssembly on our CHERI systems. MicroPython, I've demonstrated that before. MicroPython is a kind of cut down Python interpreter, which again runs on CheriBSD and also on Sonata. And there are papers that you please cite if you're interested in this kind of thing as well. And can I find MicroPython here? Ooh, let's look for Python examples. Have I got those anywhere? Oh no, wrong one. Let's try here. Python examples. Good. So, MicroPython PureCap, hello. Good. And it prints hello for us lots of times. Or I can run MicroPython CurePack and then, oh dear, don't look at that. Aha, but actually, look at this. This is very interesting. Emacs out of bounds.py. So we create ourselves a byte array with 4 elements in it. We get the address of that, and then we have this bad buffer reference here, and we iterate over the first 10 elements and print them out. And if we just do this with a hybrid MicroPython, which isn't doing the bounds checks, then we happily look at the first 10 bytes of the bad buffer. But if we use the PureCap one, which has type bounds enabled, then, of course, as soon as we get to the end of the buffer, we get our sigprot, and we're very happy. Good. And so this is the runtime that you might use with your C programs, which is a plugin garbage collector. this is a conservative collector by default, but on PureCap, of course, it becomes a precise collector because we know exactly what the pointers are. This program has the world record, or this system can produce a program with the world record speed up for PureCap over hybrid because we give it a program that has lots of things that look like pointers and aren't, and it does a garbage collection, and bam, it runs super fast in PureCap precise garbage collection, very slowly with hybrid garbage collection. This is available on GitHub now. This is really nice because this has been upstreamed to the main BOEM garbage collector repo. So if you were to go to, this isn't our repo from Glasgow, this is the real BOEM garbage collection repo here. If you were to go to this one here, which is the official BOEM Demos Visor collector, and search for CHERI, then you will find lots of exciting CHERI specific code in this upstream repo here. So this stuff can build straight out of the box on CheriBSD or possibly Cherry Linux as well. Yeah, it runs on RISC-V and Morello, and we're writing a paper about it at the moment, and I could demonstrate it to you as well, perhaps. Could I? Yes, I think so. Yes, if I can remember what I'm doing. No, maybe not. Oh, that might do. Oh, no, that doesn't do. Okay, never mind. Yes. Oh dear, it's all gone horribly wrong. Yes, I definitely have got a program here somewhere. Oh, I know what I can do. I can look for test bounds. Does that work? No, it doesn't. Oh, how annoying. Okay, I did have a program that would have demonstrated BOEM garbage collector, but don't at the moment. Right, okay, so these are just 4 language runtimes which run out of the box. You can compile them from GitHub and run them on CheriBSD directly, and others are available. Well, maybe. So there is an OpenJDK hotspot runtime for Java programs, which isn't yet open source, but if you talk nicely to people from Manchester University, you might be able to use. There's also V8, which is a JavaScript engine, and again, capabilities limited of working on this and might be available for public use. Should be.
But whether you should use it is another question.
Ah, yes. Okay, yes. I think it's, yeah.
How stable it is,
I know. So, to be honest, that's probably the largest and most complex runtime that has been or is being imported to CHERI, I think. Yes, those two there.
7 different just-in-time compilers.
I know. Yes, just-in-time compilation's a problem. And then there's also CPython, which again, Cambridge University folks are working on and might have some uses as well. Good. These things are harder to build and your mileage may vary and the source code isn't always necessarily available. So, very quickly with my last minute, what needs to happen next? We need to get these virtual machines into the operating system package manager. So you can just say, package 64C install MicroPython, and it just works nicely. We need to be able to showcase CHERI features in the high-level languages so that when you do things that are bad in the high-level language, CHERI kind of traps for you nicely. And we need to be able to adapt these things for different CHERI platforms and systems. How can you help? Join the CHERI Virtual Machines Working Group. There's the email address there, or just contact me. Consider which VMs that haven't been ported should be ported, and if you know of any that have been ported, do a pull request on this GitHub repo here, and I'll add the information there. So this is a list of virtual machines you can run on CHERI. Yes, and do send us bug requests. No, bug reports and feature requests and other feedback. Not bug requests, bug reports, that's what I meant, yes. Good, thank you.
Do you have debugging support for that? So if a developer wants to know which line that exactly caused this CHERI violation, is it possible?
Oh yeah, debugging support. So it's certainly the case, oh, thanks very much. It's certainly the case that some of these things are integrated with GDB. Yeah, like the bone collector and so on. Other ones, if you use the kind of native debugger, then that will work for you. So for instance,
can you print an error which line has caused this CHERI violation, for example?
Yes, so some of the virtual machines do have that facility, but not all of them. Yeah, that is definitely helpful. Yeah.
Thanks.